Hey everyone, so today in this recording, we're going to start with polynomial operations. Actually, what we're going to do is break down the polynomial function and how it's put together. Then we're going to do some adding and subtracting of polynomial functions. Now, one of the things I do want to say, of course, is we will do multiplication in a different video, okay? So first of all, a general polynomial is set up like this, where your A, B, and C are numbers, okay? The biggest thing to keep in mind is that your exponent, your B, has to be a whole number, okay? Whole number. So 0, 1, 2, 3, 4, 5, 6, 7, so on and so on, okay? So hence why it says home. Sorry, guys, I'm a little off right now. All right, so what else can we, because there's different breakdowns in terms that we can use. So this is all about vocabulary at this point. Now, I wrote the definitions out ahead of time. So what I would do is when I'm done explaining, pause the video so you can write down the definition. I didn't want to take time up by writing it down because I write slow. Okay, so the first term we're going to talk about is standard form. So when your polynomial is given to you, it doesn't mean that it's in a certain order. But lots of times a question could ask you to have it in standard form, or it could, you can identify things better if it were in standard form, okay? So anytime it's asked about standard forms, what it means is each term is put in order by exponent. And specifically the exponent, you would go from highest to lowest. I guess I am writing. Okay, so that's what it means by standard form. The next term we're going to go over is a leading term. So out of all the terms in a polynomial function or expression, you have a leading term. The leading term would be the term with the highest exponent. Hence, when you put it in the standard form, your leading term is out front. But if you don't put it in standard form, leading term doesn't mean the first term you see. It's the term with the highest exponent, okay? Degree. The degree of your polynomial is all based on the highest exponent. So like the highest exponent of 2 would be a quadratic. The highest exponent with 3 would be a cubic, so on and so forth. Then we have leading coefficient. So leading coefficient comes from the leading term. So you have to identify the leading term, and then the leading coefficient is that number in front, that coefficient in front. Next term is constant. Or constant is the term without a variable. Or you could think if there was a variable, that exponent would be 0. And I give you an example right here. So the constant that we think of just a number with no variable would be 3. But technically, if it had a variable, it would mean that the exponent to that variable is 0. Because if we remember our exponent rules, anything to the 0 is always the value of 1. Okay? So again, stop that video if you need to write down those terms. And these are some classifications of polynomials, what you call, of course, when 0, 0. If you have any number, the 0 in the degree is a constant. Highest degree is linear for degree 1. Highest degree 2 is quadratic, cubic, so on and so forth. Okay, so now let's go in and see if we remember what to do. So a standard form, remember standard form as highest exponent to lowest, okay? So if I look here, I have a 4. Now remember x to the what? It is the value of 1, right? X to the first. There's our constant, that's x to the 5th, x to the 3rd. So which term goes first? It would be 5x to the 5th, right? That's the highest exponent, and it's a positive 5, so I kept the positive right there. The next one would be x to the fourth. So that would be plus 15x to the fourth. Next one is to the third. So that's negative or minus 18x cubed. Then we don't have a square, so we don't have to worry about it, but we do have x to the first, so negative 23x, and then plus 8. And now we just wrote our polynomial in standard form. So from there, what we can do is this. The degree, remember, the degree is the highest exponent, so that would be the fifth, right? The constant is the one without a variable, so that is 8. Leading term in standard form, or the highest exponent term. So that would be 5x to the fifth. And the leading coefficient is the number in front of that leading term, which in this case is 5. Very good. All right, so now we're going to do some adding and subtracting. We do have some methods up here that you can choose to do. I actually do it a little bit differently, and I'll show you my way. But you can go with the horizontal method. You could do with the vertical. But remember that adding and subtracting is combining like terms. And to have like terms, you must have the same variable and the same exponent. Okay, same variable, same exponent. My strategy that I use when adding and subtracting polynomials is I actually draw shapes around identical terms, like terms, right? So I would do something like this. All right, this first term is x cubed. Do I see another x cubed? Yes, I do right there. So I'll draw a circle around it. The next term here I see is x squared. So I'm going to draw a square around it. Do I see any other x squareds? Yes, I do. As you guys can see, when I do my new shape, I'm putting the adding or subtracting sign in with it because I want to remember that. Think of that as a -3. Okay, so when I combine the other ones. Let's see. Let's do a squiggly line for the x's. Squiggly line. And then my constant, maybe I'll try to do a diamond. Again, you do not have to do my strategy if you don't want to. It's just easier for me. Okay. So again, I would like my answers probably in standard form. As you can see, it says standard form up here. It depends on your question. So of course, I'm going to do highest exponent to the lowest. So the highest exponent here is x cubed. So I have 2 x cubes here. How many x cubes do I have right here? I have 1 x cubed. So keep that minus, not 0 x cubes, it's 1. So 2 plus 1 is 3. So I have 3 x cubes. Now remember, when combining like terms, you do not change the exponents. Like if I'm adding green apples, they don't change to red when I put them all in one group, right? They still are green. Okay, and then my next term after cube is squared. So I have a -3 and a 2. -3 plus 2 is -1. Now, I'm going to put the -1 x squared because that's what we are doing, right? X squared. Do you have to put the 1 in there? No, you don't. You could put minus x squared. That's totally fine. Okay, let's go to our x's. So we have 4 and -5. 4 minus 5 is -1. I'm just going to put negative x in this case so you can see what I was talking about before. And then we have our constants. -1 plus 3 is +2. And we are done. We just added 2 polynomials. Okay, so example 3, we have adding again. But in this case, this is what I'm saying, what's different with example 2 is example 2 was in standard form already. So it was easy to identify to put my answer in standard form, okay? Whereas example 3 is not. So either you can put it in standard form ahead of time and then add, or you can just do it at your own pace. But remember the directions on top here said put it in standard form. So highest exponent for your answer. Okay. So let me do it again. I'm going to circle this 2x. Are there any x to the first? No, they're not. So that's only circles, right? The constant here of -1, I'm putting a square around the constants. I'm going to put a square around that 4. I'm going to put a squiggly line for the x squareds. And then look, I only have one term left, so I'm just going to remind myself that that's by itself, right? Okay, again, I didn't put it in order, but now I do have to put it in order. So let me look at all my terms. The highest exponent is x cubed, but as I can see, there's no other x cubes that I'm going to align with, so I'm just going to keep it as x cubed, because highest exponent first. The next exponent would be x squared. I see I have an x squared here and an x squared here. I have 1 here and 3 here. 1 plus 3 is 4. Okay, I got my x squared. Let's do our x's. Well, there's only one term to put together, and that term has positive 2x. Now we're going to go to our constant. We have -1 and 4. -1 plus 4 is a positive 3. And that is in standard form, so we're ready to go. Next one, as you can see, we pointed out what's going on here. It's subtraction. We're taking away. So if you're really good with your subtraction, you can do what you did up here, but you're not adding, you're subtracting, or you could do what I do. I tend to make more mistakes on subtraction. What do I not make mistakes on? Adding. So remember, subtracting a full parenthesis is the same thing as distributing that negative out. So the first step I do is I keep my first polynomial the same. Because technically there is an addition in front of that. It's a positive. But now I'm going to distribute this negative out and actually make each of these terms opposite to what I see. So now it would be a negative 2x squared, negative 2x cubed, minus x squared, right? Opposite, plus x minus 2. See how all those are opposites? Okay, now I can combine, I can actually add them just like I did up here. So I'm going to do shapes around my terms, right? So I'm going to go a circle around the x squareds. Let's do a box around the next one, right? My x's. The squiggly line around my constants. And here I have an x cubed, so that's by itself. Okay, remember, standard form, highest exponent for this example is what? X cubed. It's a negative x cubed. Let's look at our x squareds. We have 4 here and a -1 here, right? -1. Write it in if you have to. 4 at -1 is 3. And we have our x's here. We have 3 here and 1 here. 3 plus 1 is 4. Thanks. -4, -2 is -6. So again, with this one, with example 4, if you want to keep notes to yourself, is you could distribute first and just combine, add those terms. Or if you remember correctly, you could be like 4x squared minus x. You know, I don't like this one. Which one am I doing? Oh, this one. 3x minus -x. See how you can make mistakes? So I think it's easier to distribute first. All right, so I'm having you practice stuff on adding, subtracting, and identifying the vocabulary.